Offshore Mobile Marine Energy Testing Facility. Since the second industrial revolution, the world has become increasingly dependent on electricity to power our way of life. However, a significant amount of this electricity is generated from burning fossil fuels, which generate vast quantities of pollutants. The world is now focusing its attention on developing renewable electricity generation technologies, which are capable of exceeding the world's electricity demands. One significant source that we can harness energy from is the ocean.
Marine energy technologies harness the chemical and potential energy stored within the ocean to generate electricity. Examples of marine energy technologies include wave energy converters, tidal stream, tidal range, ocean thermal energy conversion, salinity gradient, deep ocean current, and arguably offshore wind. However, many of these technologies are not yet commercially viable. The development of wave energy converters and tidal stream technologies is the current focus of the industry. Testing of marine energy technologies is currently limited to locations where marine energy testing infrastructure is already developed. Additionally, environmental constraints of the facility's location often impede the ability of the testing facility to test more than one type of marine energy technology.
A solution to this problem is a marine energy testing facility that is mobile and is located in an offshore environment. The Offshore Mobile Marine Energy Testing Facility, or OMMETF for short, will make use of existing offshore structure designs to be retrofitted into its facility. A case study of the OMMETF design was applied to the Waikato region of New Zealand.
The OMMETF design criteria were based on the designs of existing marine energy testing facilities. This generated constraints that the offshore structure design had to facilitate, and was identified that a jackup rig was the most suitable offshore structure to be used as an OMMETF.
GIS is a mapping software that allows for a multi-dimensional data to be managed, processed, and analyzed. The proposed site selection methodology, in conjunction with GIS, determined the most suitable sites for the installation of a facility by processing collected data into constraints, restrictions, and exclusion zones. Through the application of GIS, the initial scope of the project was changed. Tidal, which was initially considered to be tested for the OMMETF, was deemed unfit for the testing due to the insignificant tidal energy that the Waikato region generated. Instead, wave energy analysis was focused upon Waikato's west coast due to its significant wave energy potential. The proposed site selection approach identified an offshore location near Kawhia as the optimal site for the OMMETF. The site's location was chosen due to the optimal wave energy potential of 10 to 30 kilowatt per meter at sea depths of 20 to 60 meters. These parameters allow the facility to conduct full-scale testing in sea conditions suitable for marine energy technologies. The ranges of energy and depths also allow the facility to easily move from rough to benign sea conditions, allowing adaptable marine energy testing, showcasing the advantages of an offshore mobile marine energy testing facility.
A jackup rig design that could be retrofitted into an OMMETF is the Zentech R550D jackup rig design. The R550D is capable of withstanding the toughest sea conditions that it will be exposed to at the Kawhia test site. The facility will be equipped with 3 to 8 test berths on the structure to create a connection point between the facility and the devices being tested. In addition, a data receiving facility and laboratories will be added to the existing cabin space on the rig. It is proposed that the facility will be powered by electricity produced during the testing of wave energy converters, with excess electricity stored on board Tesla megapacks that will store excess electricity and supply the facility when testing is not occurring.
With Kawhia being known for its cultural presence, it is paramount that the facility complies with both the local community and the iwi's respective wishes to encourage environmental and spiritual success within the region. Therefore, the future works of this facility will include the approach and start of a synergistic bilateral relationship with both the iwi and the community. This will involve discussing the iwi, how their values and beliefs can be implemented into the facility, community employment, and open dialogue with their opinions in all future business endeavours.
Further investigations must also be conducted to determine the electricity demands of the facility and to refine the process whereby electricity generation of the devices being tested and electricity demands of the facility are suitably managed. Finally, the facility concept should also be applied to a tidal stream testing context. No suitable tidal test sites were identified in the Waikato region. However, in order to make the most of the OMM ETF concept, it should be able to test both wave energy and tidal stream technologies.